we will quickly give an update on where we are with respect to 0.5.3 and what are the kind of issues that we are fixing for 0.5.3. And then in the light of recent messages on the OpenEBS users channel of volume getting into read-only, we want to see, we want to dig a little bit deeper into how to debug such issues, or how to probably what are the workarounds or how to avoid these kind of issues. Right. So I'll get started quickly with 0.5.3. Let me open up my screen here. So 0.5.3 is a bug fix release, primarily targeting at making the Helm charts more flexible, so that we can merge this into the Kubernetes incubator charts repository. The things that we're doing is remove the hard coding with respect to the Maya API server. The PR for getting that done is merged. So on the provisioner side, now the thing that's pending is to kind of update the Helm chart to remove that hard coding. That's one thing. In addition to that, we've observed that most of the people are actually installing OpenEBS in its own namespace. So we're making that as part of the Helm chart itself. There's a configurable namespace option in the values if you see the latest merge, which will put all the OpenEBS related services into its own namespace. And there was also one bug related to the default pool not getting created, or even if it is getting created, there was some hard coding in the code that would not take the new directory associated with the default directory. That's also been merged as part of this 0.5.3. Okay. A few cleanup activities are remaining, mostly like the troubleshooting document update and all that. Those are the open bugs right now. Okay. Are there any other items that you would like to see fixed on an immediate basis on a 0.5.3? Anyone on the call? Cool. Are there any other issues that you're seeing other than the one that is the volume getting into read-only due to the network issues that we should be discussing?
Kiran?
Yeah.
I think probably we can spend a little bit of time on, especially since Ryan also is here, about the debug container that we are speaking about, generally the expectations from it.
Sure, go ahead, Karthik.
Yeah, so probably probably we could discuss this like once we touched upon the read-only issue and the approach that we're taking to debug that. So in general, so since the user channel, a lot of people are asking about the recovery steps, and they're describing their issues, and we're asking them for the logs from the node and from the pods. So it was decided that we'll try to come up with a debug pod, so to say, which will run some logging agents like Stern, which is the one we have considered now, to get the logs of the pods we're interested in, the OpenEBS operator pods, that is Maya and Provisioner, and also the volume pods, the PVC pods, in addition to some of the other node logs. So generally, the approach towards logging is to either to use something like Fluentd pods in the environment. Sometimes, if it is a hosted environment like GKE, people are seen to enable the stack driver logs, etc. So we are trying to come up with a logging solution which people can use if already they are not configured with any such logging agents. So what is the best approach to go ahead with this? The Kubernetes documents describe the sidecar approach, wherein each pod has its own sidecar which contains the logs, or to just have a on-demand job that can be run and just collect the logs and exit. Like, what is the best practice there is one of the discussion points I wanted to talk about.
Sure, we probably go ahead with that discussion right now, and then switch into the walkthrough of the provisioning steps part. Uh, I think basically we're trying to gather inputs, team, on what's the best logging mechanism that we can put in, or uh, how do we augment the logging infrastructure that users already have, right? So Ryan, maybe if you could just spend like a couple of minutes explaining how you work on the logging, or how you take care of logging in your Kubernetes cluster. Maybe that can help us.
Kiran?
Yeah.
I think your voice is trailing off a little bit, Kiran.
Okay. Is it any better now?
Yeah, yes.
Okay. Ryan, do you have any inputs to share in terms of how you capture the logs from the Kubernetes clusters? Do you use any frameworks, etc.?
Yeah, so I don't think that OpenEBS should be responsible for creating any type of infrastructure when it comes to logs or even the log infrastructure. I think that should be left up to the end user. Currently, in our infrastructure, we're using, Fluentd, and we're using, a daemon set with sidecar deployments to collect logs. But I don't think that there should be a default expectation for OpenEBS to collect, aggregate, or any log centralization. But that's just my opinion.
Right. That's a good point, Ryan. I think one of the maybe this is also like a bit of a learning from our side. The patterns that are being followed for the containers, what I've heard is we should just dump it to the std out of the container, and the like the way the Fluentd or somebody else will be able to capture that logs and send it to the centralized logging. That's is that a fair assumption to make? Will that serve most of the cases that you have seen?
That's kind of the state of Kubernetes and Helm as it is right now. There's so many different situations as far as log aggregation goes. You can't make any assumptions. So as long as the logs are actually being sent out to standard out or standard error, I think you're good. I don't think you should spend any time thinking about, like I see Prometheus as being deployed, automatically. Like that should be cut out. As long as logs are being sent out to the standard paths, I think that's good.
Thanks, Ryan. I think that helps. Yeah, I think people will have, or like the developers would set up their own logging infrastructures, or the cluster admins, and then we should totally depend into that one to collect the logs. Okay. All right. So I've just put together some slides here just to walk through the provisioning process, which I can. I also wanted your input on a couple of things here.
Is anyone else hearing jitter? Like for the voice?
Can you also saying that my internet connection is slow?
Hey, Kiran, are you able to hear me? This is Amit.
Hello.
Yeah. Hey, Kiran, I think your voice is breaking in between. Sometimes it's completely inaudible.
Hi, Kiran. Yeah, we are able to hear you.
Okay, sorry. Sorry about my connection problems today. Can you see the screen again?
Yes.
Okay. So Ryan, this is the presentation that we're planning to give it to the CNCF storage work group, which is actually on Feb 28th. It's a basic introduction of OpenEBS, and then explain how it works at a very high level, and then get into talking about some of the storage problems that are being solved as part of the OpenEBS team, right? I will actually use the same set of slides today to show how it works. But as part of this story, a couple of slides here on especially you, right? Would you be comfortable with this slide being there, or do you think it's too early?
You broke up a bit. Can you repeat that, please?
I will try again. About my connection. The slide about the OpenEBS, and then shows at a very high level how it works, and then talk.
Hey, Kiran, I don't know if you can hear me or not, but your audio is pretty horrible. I don't know if anyone else is experiencing the same thing.
Am I audible to everyone?
Yes,
I
Amit.
hear you fine.
Oh, okay. Okay. Thanks. Great. So I will be taking over from Kiran since his connection is a little bit having a problem. I'll just try to run through the slides and okay. So, all right. The screen is still shared from Kiran's laptop. Is the screen visible?
Yes.
I think I will take over the screen.
Yeah, I can see it fine.
Yeah. Okay. Okay. Just hold on. I'll just take it off. I just want to get the link of the slide deck. If you can post it immediately, otherwise I have to search it.
Chat by Kiran already.
Talking of
Zoom chat.
so okay, I'll be going through the slides, but then I just wanted to come to this slide, that is a slide number 4. Basically, this is like we are taking up a DevOps persona here and trying to really write down what exactly goes in the mind of the DevOps admin when he's trying to run a Kubernetes cluster, right? So the question here is for you, Ryan. Are you like comfortable with this slide? We are actually going to use this slide deck for the CNCF presentation.
Yeah, I'm comfortable.
Okay.
I don't like the picture, but yeah. Otherwise,
Okay.
I'm good.
All right.
That's vanity. Keep it.
Okay.
The best part is the picture.
Yeah, that's right.
It's a
Okay.
Rehan's picture.
Yeah, that's right. All right. So let me then go through this slide deck. So this is for the upcoming CNCF presentation, which will be on February 28, 2018. All right. So this is typical the overview of OpenEBS when it got created and all the statistics related to OpenEBS. You know, okay. And at a very high level, we'll be trying to answer out these questions like where does OpenEBS fit? What problem does it solve? How is it an integral part of Kubernetes? And then the basic Q&A kind of stuff, right? All right. So again, the Somalia data is something that is supporting OpenEBS as a open source project. Somalia data is one of the companies behind OpenEBS, right? And the primary focus here being the storage that enables the teams to achieve their agility, right? So the storage needs to fade away with OpenEBS and Kubernetes in place. The team need not think about storage, whereas the storage will automatically be applied. The storage should run smoothly without posing any problems. And again, due to the architecture, the OpenEBS is being built. It's a kind of a microservices. It's a containerized storage, and of course, it's open source, open to the community, open to the community's contributions. That's how OpenEBS is trying to get into the DevOps world by taking the feeds, the inputs from the community, and applying it in the OpenEBS into the Kubernetes. Right. So here is a story of a DevOps admin who tries to manage around a couple of Kubernetes clusters, right? Okay. All right. So I guess Kiran has written down these comments. Rehan, if you think any of these comments needs to be modified, you can definitely maybe chat it to us. You can post some comments maybe after this, or we can even have some chat after this presentation is over, right? Okay. Right. So coming to the persistent volume categories, I guess. Right. All right. So what we see here is I'll just say like from the left we have something called network attached storage, which is what we have been seeing till now. It's all there. It's all proven. However, we see there still are the chances where it is not suited for the containers. The reason being that is a kind of a bridge that needs to be made for these legacy NAS kind of applications to be fed into the containers, which runs in its own cluster, right? However, this has been the proven model. This is how the things work still now, right? And then on the other side of the spectrum, let's say to the right, we see the CAS. That is the container attached storage, right? Which is where the OpenEBS is trying to fit in. And in between, we have the direct attached storage, which is nothing but get the storage out from the nodes, from the machines which has got the storage attached to it, right? All right. So cache is something like it is a hybrid model where it has got the benefits of it definitely gets all the benefits of the DAS, as well as it is able to get the storage out from the network attached storages, for example, EBS, right? And added to the fact that it will have all the features that a storage demands, for example, snapshots, replication, encryption, and all. Right. So this is more about the container attached storage. What exactly is that? We are trying to showcase. We are trying to write it down here. So this is the targets will be running in the containers. That's what is the containerized storage, right? The entire storage is in the user space and it is running inside the containers. The storage containers are orchestrated by Kubernetes, just like any other workloads. Right. So what OpenEBS tries to do here is it doesn't try to differentiate between a stateless versus a stateful app, where OpenEBS itself is run as a kind of a stateless app, right? Where the state is being maintained in Kubernetes via the features like custom resources and so on, right? So the storage itself has become a kind of a stateless app being managed by the Kubernetes, right? So there are a lot of benefits to be achieved in this mode. For example, the upgrades, which is like really a pain when we think about upgrades to a storage. Let's talk about the patches. When the storage is run from a machine that is dependent on a kernel, and we think about patches, all the applications that depend on the storage have to have a kind of a outage, or a dedicated defined time needs to be taken for that, right? And the list goes on, like monitoring debuggability and so on. The features that Kubernetes has exposed for the stateless, for the usual stateless apps, for the typical stateless apps, can all be achieved using this CAS model. And that's nothing but the OpenEBS model, right? Okay, so the storage containers are mainly dealing with disk storage management, data high availability, and data protection. These are the typical things that the storage controller will be having. In other words, OpenEBS will be having, right? Which is specific, very, very specific to the storage qualities, right? So this is about OpenEBS volumes. Okay, so we see here there are a couple of nodes, right, which has got some disks. This can be exposed as a file system or as kind of a block device. And on the other hand, we also see how they are actually achieved, right? How do we expose these devices into the containers? Those are like the typical Kubernetes objects on the storage class. Okay, when it comes to storage pool, this is one of the concepts. This is the concept that OpenEBS has come out with. And again, this is an extension to Kubernetes. When I say extension, it is a custom resource of Kubernetes that OpenEBS uses to expose the disk level qualities, the disk level characteristics of a node, right? And then we see an application which will bridge to the storage via its PVC. All right, and the blue rectangle that we see here is a application pod, and which will result in an OpenEBS volume. And when we see OVCTRL, it means an OpenEBS volume controller, which is nothing but the SCSI target. And then we see OpenEBS replica. The replica is nothing but the disk or the one which is doing the IOs on the devices. And then there is a replication factor that OpenEBS volumes comes up with. The replication factor can be, let's say, more than 1. And in this case, we see that the replicas, that is the devices, are replicated to the other nodes. By default, these replicas have an anti-affinity policy, which spreads them across the nodes, right? In other words, there'll be no 2 replicas which reside on the same node.
Can you speak quickly about the affinity policy?
All right. Yeah, Ryan. So, so the affinity policy is the Kubernetes policy, that is the pod anti-affinity policy, which makes use of labels. If you ever get into the replica YAML description, you will see that there is a pod anti-affinity policy which says that if a pod that is a replica having this label is present in this particular node, then there should not be any other replica with the same label on that same node. So this is basically the anti-affinity policy of a replica.
All right, thank you.
Yep. Right. So so we have OpenEBS volume that is currently being exposed as a iSCSI persistent volume. Currently, OpenEBS supports iSCSI. Right, and then yeah. So OpenEBS. Yeah. So all right. So I think there is one more stuff that is not mentioned here in the orange boxes, which is nothing but a Kubernetes service that also plays a role here. Kubernetes service is the one which is exposed as the target portal that a SCSI service that the application will be using. That cluster IP of the service will be used as in the target portal. So this in turn means the stateful workload, that's the application, will be using that particular target portal to make connections or to make sessions to the SCSI layer and run the IOs. All right, right. So what exactly is OpenEBS control plane? This is what a typical Kubernetes cluster has, right? A default installation. Right, and fine. The boxes in orange are the ones which are installed via OpenEBS, and these are typically the control plane stuff. The provisioner is the one which is a Kubernetes storage provisioner. It's a dynamic provisioner, and the API server, the Maya API server, is the one which exposes REST endpoints. In other words, the provisioner will be invoking API server to provision the volumes, or for example, to create snapshots, to restore them, to delete the volumes, right? All right. So this is a feature which is you won't. It's not fully. It's a under progress, in progress stuff. So this is all about disk management, right? So this is kind of thing which will take over the storage pools. For example, this is the advanced feature of storage pool. Currently, the storage pool expects the admin to do these, to create the partitions, to discover the disks, create the partitions, and then create a mount point, and then put that mount point in the storage pool, right? Those custom resources, right, in the path. So this is a lot of manual task involved, and all these manual tasks is supposed to be automated via the Maya node bot. And this is OpenEBS disk management component, right? Yeah, when the node board comes up, we see the SC and the CRD. That's nothing but the storage pools and the volume policies. Yeah, of course, the volume policies again are a feature which will be introduced in OpenEBS 0.6.0. This is, I guess we had some of the videos linked to volume policies earlier. This is, in short, this is all about finely granular policies, finely granular storage policies that can be, that can be directed to OpenEBS. for example, replicas, for example, snapshot scheduling, for example, quota, the QoS policies, those kind of things will get into the volume policies, right? Right, and these are some of the things which are kind of optional, like we were discussing some times back. The cluster or the team might already be having its own preferences. However, these are some of the things that OpenEBS supports currently. When we talk of monitoring, OpenEBS has a Prometheus-based exporter, which exports the statistics to Prometheus endpoints. Compatible, it's Prometheus compatible. And of course, Grafana and the dashboard are all available in Kubernetes. If desired, these can be used. All right. So on the whole, these are all the OpenEBS control plane, right? And if you see, the half of the things are being managed, or more than half of these things are being managed via Kubernetes, and OpenEBS makes use of them. And wherever desired, it creates its own controller, which runs in its own pods. Right. Okay. Right. So this is all about the control plane. And if you see, this is all open source. It's all present in the GitHub OpenEBS Maya repository.
Amit?
Yep.
I think this is, can you hear me okay?
Yes.
Yep. Okay. Let me see if I can, at this point, switch to the demo. This is basically the slides that I had in mind, but the main intention also was to show them in the logs, right? Let me see if I can share the screen. Let's just try this once more. Hopefully it will work this time.
Okay. So I'm stopping the share from here.
Okay. Is my voice better now?
Yeah, it seems better.
It's better.
Okay, cool. So I have a small cluster here that I've created on GKE. Let's see, kubectl get forwards. Okay, and I'm actually running the latest operators here. kubectl forwards -n OpenEBS, where the OpenEBS components are actually installed in a namespace called OpenEBS. As Amit said, the API server and the provisioner are the main components that are there. Grafana and Prometheus are really optional. Those are mainly provided as a demo options. Okay, so to check the health of these things, I think the main thing is to make sure that before actually launching the volumes, the main thing is to make sure provisioner and API server are up and running. Without that, the PVCs that are tied to the OpenEBS storage class will not be provisioned. So let's see the logs for OpenEBS provisioner, which will be the entry point for Kubernetes to provision volumes. What did I do wrong there?
Namespace.
Can I keep it like this? No.
Just dash in.
Okay. So the initial startup logs usually at this point, right, starting the provisioner controller, if there is any issue with respect to attempting to talk to the Maya API server, that will be logged in the starting, and then it just gets into the crash loop back. So the first step is to kind of make sure that provisioner is successfully has successfully started without any errors in contacting the MyAPI server. Right? We have seen a few issues related to that one, where you won't actually get the provisioner to start itself. Okay? And one of the things that I noticed with the logs with respect to the provisioner is it kind of gets into a verbose mode, especially with a lot of PVCs getting moved around. Let me actually open up one sample log file here. Hopefully I have it. Just give me a minute here. All right, let me switch back to that once I finish that one. I want to basically show some of the logs that I've been analyzing from the OpenEBS issues yesterday. Okay, so this is mainly about the kubectl logs. Sorry, OpenEBS provisioner logs. So whenever a volume is created, this is a success scenario where we are getting a request for provisioning a demo volume 1 claim, and in this case we have been able to successfully create it, right? And this demo volume 1 claim has been associated with the PVC name WD73E1, right? Okay. So now for the same thing, let's look at the MyAPI server log. Sorry. Okay, so this is all about the initialization of the MyAPI server, and then we're starting to provision the first volume here. And as part of this, this is how the policy gets enforced. For example, this one doesn't have a default storage policy added as a CRD, so it says not found, and so it goes back and defaults to var OpenEBS folder. Right? Okay, and then it's kind of taking the replication count and all that from the policies, and it has gone ahead and created the volume. OpenEBS, though it is running in OpenEBS namespace, the PVC can, in this particular case, is coming from the default workspace. So all the volume controllers are provisioned in the default workspace. So kubectl get pods. If you look at, this is just about the application. Let's look at the deployment for this one.
Is there currently a way to make the storage pods be provisioned in a particular namespace, or is it always going to be default?
Okay.
So the OpenEBS services and pods are running in the OpenEBS namespace, but the PVCs, like the storage pods, are running in the default namespace.
Right.
Can you specify where those are created?
I think right now it gets into the same namespace as the Percona. For example, like wherever your application namespace is, it goes and provisions it in the same namespace. In this case, I just have it as a default, but I could actually have a Percona namespace which will launch Percona as well as all these PVC objects in that same namespace. That's a current behavior. Do you want it to change it so that, let's say, Percona is in Percona namespace and all the PVCs are in, let's say, storage Percona namespace? Is that what you're saying?
No, I don't have an opinion. I was just curious. I don't think that they should be in a separate namespace. I think namespaces are for important things. Not saying that OpenEBS is important, but I think all the pods should be in the default namespace.
Okay, cool. To answer that question, I think we are tying it to the application workload. We don't have a way. Maybe we can explore that. Okay. So with this particular PVC, the kind of Kubernetes objects that get created when we launch it is, the first one is Kubernetes get SVC. We create a service. Okay. In fact, the first step is to create the service and get this cluster IP for the target that we are going to be running. And then creates a couple of deployments there. Let's take the replica deployment. Okay. So as of today, the count of replicas is 3. One of the things that we are contemplating is, should we actually have it as a replication controller or kind of move away into individual deployments itself so that we can make it sticky to a particular node. That's still up for debate. But right now it basically uses this deployment with 3 replicas. Okay. And this is the affinity label that Amit was mentioning earlier. So we know that this is the PVC that we are provisioning. So we put that into that label. Okay. And the cluster IP that we assigned using that service being passed as an argument to the replication pods. Okay. So one of the things that these replication pods do is once they get spawned, they will be trying to auto-register themselves with the controller pod. So these are like totally asynchronous. There is no order in. We don't have to have them start off in some order. They can be spawned independently as and when they get scheduled, and they will automatically register with each other. Okay. And the other key thing in the replication deployment is the way we provide the host path. So in this case, it's a default policy. So it's var OpenEBS. And we create a directory with the PVC name, which will be given as a storage path to that. the controller is much simpler. The controller is completely stateless. So we are currently just running it with one replica, and it doesn't have any volumes associated with that, right? This one though has the sidecar for a Prometheus exporter, which is given by M exporter image. Okay. Now, getting back to this particular slide here, I'll not start it in on animation, but so let's say like whenever the user needs an application, a pod gets automatically scheduled. A pod gets scheduled to a node, and then the PVC creation process kickstarts. And as part of the PVC process, we have created the service. We have created the controller pod, the replication pod, and then the dynamic provisioner also creates something called as an iSCSI PV. And let's now see that one. kubectl get PVC. We would be looking at the demo vol1 clean, and once the OpenEBS dynamic provisioner provisions the volume, we will see it bound to a particular volume here. So now let's look at the get PV. So what's the configuration that we have created? So the key thing is this information. This is what the dynamic provisioner puts in. From the service IP, it basically gets the target portal and then the IQN of that particular volume. Right? So the provisioner is really lightweight. It just creates the controller and the replica pods and then creates the PVC. The heavy lifting of attaching the PVC to a certain pod, etc., is taken care by the Kubernetes itself, because we use the iSCSI PV, which is also like an entry volume that's supported by the kubelet. Right. So now let's look at what the kubelet does when it gets the PV. Right. Okay, this one is scheduled on the node 5HVG. It does take some time to mount that particular volume here. So I will log in now to that node 5HVG. And I haven't figured out if there is any easy way to get the node logs or the kubelet logs from the kubectl command. Are there any that you know of? Okay. So one of the things, okay. Especially to check on the iSCSI connection part, I kind of find getting the kernel log useful. So basically, in this case, I can see that it's actually mounted. iSCSI initiator has connected to a particular volume here, and it's kind of mounted. Actually, before seeing this, there's one more command that I will grab for. Okay. This is the one that gives us a little more details on what's the way in which it's been mounted. Right now it is in read write. Doing the mount command, if the application is in a crash loop back, issuing the mount and making sure that this is in read write mode is the first step to know whether there was any network disruption and the mount had turned into read only mode. Right? Okay. Okay. And the next step would be to go and check that it's mounted. Okay. So one of the, let's say if the volume is not mounted, then the next step would be to go and check on the kubelet logs. In this particular case, the volume was mounted. So I actually have a log file from one of the users. So I'm going to look here with respect to how the kubelet actually performs this. Let me just this one. Okay. So the main thing that I wanted to show here is how the replicas get basically how the replicas get scheduled, and to find out whether I'm just trying to, sorry, give me a minute here. So one of the issues that we have seen is, though we say 2 replicas, in the volumes the replicas, since they are anti-affinity, they can get into an eviction mode due to node constraints, and the replicas can get scheduled onto a third node where the data is not already available, right? In such cases, the resync process starts again from the current volume to the newly created replica, and this resync process can take a longer duration. So during that duration, the volume can be in a read-only mode, especially if the okay. I think I'll get back on that one. I don't have the diagram right. Not able to explain it in the words right now. Sorry about that. Okay. Ryan, do you or others do you want to talk about something else? Kind of lost my track there.
I don't have anything else. I would just I would suggest you guys take a look at Chaos Cube and how it impacts OpenEBS PVCs. Like, we've had really good performance and resiliency with OpenEBS, even with killing storage nodes.
Chaos Cube, right, Ryan? Cool.
Yeah, it's basically it intermittently kills pods. It's like chaos engineering.
Cool.
We've only seen a few issues as far, and we've deployed using OpenEBS back storage for everything from Kafka, MinIO, Postgres, and we've only seen a few issues, even when pods are destroyed unexpectedly. So that's something that I would really highlight as far as trying to convey the power of OpenEBS.
Okay, thanks, Ryan. I think that helps. Yeah. All
Kiran,
right. Yes, Peter?
Sorry, if time is one thing, if one thing is on the RO thing. So, any thoughts on the next steps, and also like any inputs from the community, like whether the scenarios, how the other things are working, any other inputs from community, that's the part, on how to solve it. Was I clear, Kiran, or?
Cool. Yeah, I think then a few things that we are doing. I think we definitely need more inputs from the community on how to make it more resilient, right? Both the issues that we have seen right now with the read-only is longer duration of network failures that are actually that are causing this initiators to get into a read-only mode. In fact, like there are some cases where it's more than 1 hour or 2 hours of loss. And also, like the second issue is with respect to this is where I'm finding it a little bit difficult to articulate this particular problem. So the pods the replica pods are moving across the nodes in a very they don't stay in one node long enough so that the sync can complete. And also, like having the replica count as 2, we lose the quorum, and then the controller kind of puts the volume in a read-only state. And then that impacts the client initiator to put the volume into a read-only state. And later, when the sync is complete after a while, the volume doesn't automatically turn back into read-write mode, right? Those are the kind of issues that we're seeing. So few things that we are exploring is how do we kind of monitor the state of the volumes, and then maybe take some corrective actions of mounting it into read-write once everything is fine on the OpenEBS side, right? Maybe like mount it, run the FSCK, and then put it back into read-write mode. Actually, one thing that I might want to show here, if I can find the screen.
Hey, Kiran, when you guys are seeing like you said a couple hours delay in read-only mode, is that only during like migration?
So yes, the migration is a bigger part, one node to a different, and it's also kind of elevated by some kind of an intermittent loss of connectivity between the API server to spawn the replica pods on, thinking that replica is not running, it is actually spawning it on a different node. And then when the connection gets established, it sees the deployment count or the replica count is only 2, and then it tries to kill one of them, right? And then the way it is killing it, it could be actually killing the guy that's almost finished syncing. Those kind of issues, Ryan.
So is this a big? Are these significant data volumes, or are these like novel?
So these are MariaDB volumes that are showing that. And then also there is a bit of a problem of the network interconnection between the nodes itself, right? So the sync is actually taking more than like say 20 minutes or something. But then by the time it finishes the sync, it kills one of the replicas which is almost done, and then it tries to spawn it on the other node. And then the entire duration can go up to like 40 minutes or like 1 hour in some cases.
Interesting. Okay, thank you.
Yeah. I think the chaos thing is probably one good thing, and then to kind of get these things out even before it hits a environment where such cases are more prevalent. The other, right now we just have this pod anti-affinity based on the label, which is also the reason why it gets spawned on other nodes. So we are also trying to look at how to make it sticky to a particular node and be more resilient towards this, right? And basically having 3 replicas would have helped in this case.
Hey, Kiran, Amit here. Let's say, for example, we have 3 nodes, 3 minions, and 3 replicas that are spread across all these minions, right? However, there is, let's say, there are issues with the network. All right, for some reason, Kubernetes restarts or tries to evict these pods, the replicas, right? In such a scenario, do you think still, we'll be in a read-only state if like this, Kubernetes keeps on restarting due to some of the other issues? I guess the OpenEBS will still be in a read-only state, right?
So as long as, if we lose the quorum of the data, even when we have 3 nodes, right? Yes, we will get into that read-only state.
Thanks, Kiran. For explaining that issue also completely. It makes sense. The network is gone. I think you don't have an option then because of quorum loss going there. And the best part, I think I understood from your other thing is like how do we poll the things and make it like read-write once the things are good, right? I think that's good steps to start on the resolving this read-only issue. And in this case, probably the quorum of 3 nodes may help us, right? I think with the 2 nodes, we have this problem of it have to rebuild and the quorum is not available, that kind of issue. But with 3, it's just the network issues. Once the network issues are gone, we will be sure to come back into the read-write state once we have this concept of polling and fixing it.
Correct.
Thanks. That's it from me. Sorry for extending the call.
No, thank you, Vita. I had actually lost my thoughts a bit. Your question actually helped me to kind of frame them back. Thanks for that question. Okay. Right. Sorry about my network and unpreparedness for today. Apologize for that. Try to do a better job next time. Okay. That's it from my side for today.
I think are we good with the call?
Yeah. Anything else? Otherwise, we can probably stop the call. Yeah.
Yep. Bye.